Possible causes of the subboard flashovers include firstly electrical arcing. Loose connections between the circuit breakers and the main bus bar can cause electrical arcing. Overheated connections due to poor contact or high current flow can also lead to arcing. Secondly, insulation breakdown. The insulation between the circuit breakers and the bus bar may have been compromised due to aging or degradation of the insulation material, high voltage spikes or surges, or moisture or contamination. Thirdly, circuit breaker malfunction. In some cases, the 20-amp circuit breakers may have failed to trip, allowing excessive current to flow through the subboard. Fourthly, transient voltages. Switching operations in the upstream main board can generate transient voltages that may exceed the insulation capacity of the subboard. Fifthly, cable lug issues. Improper crimping or loose cable lugs at the circuit breaker connections can cause poor contact and lead to arcing. Why no loads were connected might be answered in these following possible reasons. The flashovers may have occurred even without loads connected due to capacitive charging. The subboard wiring and circuit breakers form a capacitive network that can store electrical charge. When the subboard is energized, this charge can build up, causing arcing at weak points. Also, minute leakage currents between the circuit breakers and the bus bar can accumulate over time, leading to flashovers. To resolve this issue, the following actions are recommended. Firstly, inspect and tighten connections. Check all connections between the circuit breakers and the bus bar for tightness. Secondly, test insulation. Conduct insulation tests on the subboard to identify any insulation breakdowns. Thirdly, replace defective components. If any circuit breakers or bus bars show signs of damage or malfunction, replace them immediately. Fourthly, upgrade protection. Consider installing surge protection devices or transient voltage surge suppressors, or TVSS, to mitigate transient voltages. Fifthly, ensure that cable lugs are properly crimped and tightened at all circuit breaker connections. Finally, establish a regular maintenance schedule to inspect and clean subboards to prevent future issues. Electrical arcing, in the context of power distribution boards, refers to the phenomenon where electrical current jumps across a gap between two conductors. This commonly happens when there's insufficient insulation or a loose connection. The air becomes ionized, creating a conductive path for the current to flow, producing heat, light, and sound. The heat generated by arcing can be extremely high, capable of melting metal and igniting nearby materials, leading to equipment damage and fire hazards. Loose connections are a primary cause. When connections between circuit breakers and the bus bar are not properly tightened, the contact resistance increases. This higher resistance leads to increased heat generation as current flows through the connection. Over time, this heat can degrade the connection, further exacerbating the arcing problem. High current flow through a loose or corroded connection will further increase the heat. This is because the power dissipated, measured in watts, is proportional to the square of the current multiplied by the resistance, following Joule's first law. The increased heat can cause the surrounding materials to deteriorate, leading to insulation breakdown and increasing the likelihood of arcing. Insulation breakdown occurs when the insulating material between the circuit breakers and the bus bar loses its ability to prevent electrical current from flowing through it. Several factors can contribute to this. The insulation material used in electrical equipment degrades over time due to thermal cycling, exposure to chemicals, and mechanical stress. As the insulation degrades, its dielectric strength decreases, making it more susceptible to break down under high voltage conditions. High voltage spikes or surges caused by lightning strikes, switching operations, or equipment malfunctions can exceed the insulation's capacity, leading to immediate breakdown. These surges create a transient of a voltage condition that can puncture the insulation, creating a path for current to flow. Moisture and contamination can also compromise insulation. Moisture can reduce the insulation resistance, while contaminants like dust, dirt, and chemicals can create conductive paths, increasing the risk of breakdown. Regular cleaning and maintenance are essential to prevent this. Circuit breaker malfunction refers to the failure of a circuit breaker to trip or open the circuit under fault conditions, such as an overload or short circuit. This can lead to excessive current flow through the subboard, causing damage and increasing the risk of flashovers. Several factors can cause a circuit breaker to malfunction. Mechanical wear and tear, corrosion, and contamination can affect the breaker's internal components, preventing it from operating correctly. The circuit breaker's tripping mechanism might become stuck or fail to respond to overcurrent conditions. Circuit breakers have specific current and time characteristics that determine when they trip. If the breaker is not properly rated for the circuit, it may not trip quickly enough to prevent damage during a fault. Transient voltages are brief, high-amplitude voltage spikes or surges that can occur in electrical systems. These transients can exceed the insulation capacity of the subboard, leading to insulation breakdown and flashovers. Switching operations, such as turning on or off large loads, can generate transient voltages in the electrical system. These transients can propagate through the system and affect sensitive equipment like the subboard. Lightning strikes, either directly or indirectly, can induce high voltage surges in the electrical system. These surges can travel through the wiring and cause damage to the subboard and other connected equipment. Cable lug issues at the circuit breaker connections can cause poor contact, leading to arcing. Improper crimping techniques can result in loose or weak connections. If the crimp is not properly compressed, the contact resistance between the lug and the wire increases, leading to heat generation and potential arcing. Over time, loose connections can corrode, further increasing the resistance and exacerbating the problem. When a cable lug is not properly tightened onto the circuit breaker terminal, the contact resistance increases. This can lead to overheating, arcing, and eventual failure of the connection. The absence of connected loads does not necessarily prevent flashovers from occurring. Capacitive charging and leakage currents can still cause problems even without a significant load. Subboard wiring and circuit breakers form a capacitive network that can store electrical charge. When the subboard is energized, this charge can build up, creating a potential difference between different points in the circuit. If there are weak points in the insulation or loose connections, the accumulated charge can discharge through these points, causing arcing. Minute leakage currents can flow between the circuit breakers and the bus bar due to imperfections in the insulation. These leakage currents are typically very small, but they can accumulate over time, especially in humid or contaminated environments. The accumulated current can create localized heating and increase the risk of flashovers. Inspecting and tightening connections is crucial for preventing arcing and overheating. All connections between the circuit breakers and the bus bar should be checked regularly for tightness. Use a calibrated torque wrench to ensure that connections are tightened to the manufacturer's specified torque. Loose connections should be tightened or replaced as necessary. Insulation tests can help identify any insulation breakdowns in the subboard. Several types of insulation tests can be performed. A megometer is used to measure the insulation resistance between conductors and ground. Low insulation resistance indicates a potential breakdown. A high potential test, or HIPAT test, involves applying a high voltage to the insulation to detect weaknesses. This test should be performed by qualified personnel only. Defective components, such as damaged circuit breakers or bus bars, should be replaced immediately to prevent further issues. Look for signs of damage, such as cracks, burns, or corrosion. Use appropriately rated replacement components that meet or exceed the original specifications. Upgrading protection with surge protection devices, or SPDs, or transient voltage surge suppressors, or TVSSs, can mitigate transient voltages and protect the subboard from damage. SPD are designed to divert surge current to ground, protecting downstream equipment from overvoltage conditions. Install SPD at the main distribution panel and at the subboard to provide comprehensive protection. Proper cable termination is essential for ensuring reliable electrical connections. Cable lugs should be properly crimped using the correct crimping tool and die. Ensure that the crimp is secure and that the lug is properly tightened onto the circuit breaker terminal. Use anti-corrosion compounds to prevent corrosion at the connections. Establishing a regular maintenance schedule is essential for preventing future issues. Regularly inspect and clean subboards to remove dust, dirt, and contaminants. Check connections for tightness and signs of corrosion. Perform insulation tests to identify any potential insulation breakdowns. Repair or replace any defective components as needed. Consider using thermal imaging to identify hot spots, which can indicate loose connections or other problems. Thermal imaging cameras can detect infrared radiation emitted by electrical components, allowing you to identify areas of excessive heat. Scan the subboards with a thermal imaging camera to identify any hot spots, which can indicate loose connections, overloaded circuits, or failing components. Investigate any hot spots and take corrective action, such as tightening connections or replacing components. Consider using vibration analysis to detect loose connections or mechanical issues. Vibration analysis involves measuring the vibration levels of electrical equipment to identify potential problems. Excessive vibration can indicate loose connections, unbalanced loads, or mechanical wear. Conduct vibration analysis on the subboards to identify any unusual vibration patterns. Investigate any excessive vibration and take corrective action, such as tightening connections or balancing loads. Consider using power quality monitoring to identify transient voltages, harmonic distortion, or other power quality issues. Power quality monitors can record voltage, current, and other electrical parameters over time, allowing you to identify and analyze power quality problems. Install power quality monitors at the main distribution panel and at the subboard to monitor power quality. Analyze the data to identify any transient voltages, harmonic distortion, or other power quality issues. Take corrective action, such as installing filters or surge suppressors to improve power quality. Review the subboard design to identify any potential weaknesses. Ensure that the subboard is properly sized for the load and that the components are rated for the voltage and current requirements. Consider adding additional insulation or shielding to protect against transient voltages. Ensure that the subboard is properly ventilated to prevent overheating. Consider upgrading the subboard to a more robust design with better protection features. Conduct a thorough investigation to determine the root cause of the flashovers. Gather data from multiple sources, including maintenance records, inspection reports, and power quality monitoring data. Interview maintenance personnel to gather information about their observations and experiences. Analyze the data to identify any patterns or trends that may indicate the root cause of the flashovers. Implement corrective actions to address the root cause of the flashovers. This may involve tightening connections, replacing components, upgrading protection, or modifying the subboard design. Monitor the subboards closely to ensure that the corrective actions are effective. Regularly inspect and test the subboards to verify that they are operating properly. Use thermal imaging, vibration analysis, and power quality monitoring to detect any potential problems. Document all maintenance activities and keep records of inspections, tests, and repairs. Use a computerized maintenance management system, or CMMS, to track maintenance activities and manage equipment records. CMMS software can help you schedule maintenance, track work orders, and analyze maintenance data. Consider using predictive maintenance techniques to anticipate and prevent equipment failures. Predictive maintenance involves using data analysis and monitoring techniques to predict when equipment is likely to fail. This allows you to perform maintenance before failure occurs, reducing downtime and preventing costly repairs. Implement a comprehensive electrical safety program to protect workers from electrical hazards. Provide training to workers on electrical safety procedures and practices. Use personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash suits to protect workers from electrical hazards. Ensure that all electrical work is performed by qualified personnel. Follow all applicable electrical codes and standards such as the National Electrical Code, or NEC, and the National Electrical Safety Code, or NESC. Properly size the circuit breakers for the connected loads. Overloaded circuits can lead to overheating, insulation breakdown, and flashovers. Ensure that the circuit breakers are rated for the maximum current that the circuit is expected to carry. Use appropriate wiring methods and materials for the application. Improper wiring methods can lead to insulation damage, short circuits, and flashovers. Follow all applicable electrical codes and standards when installing wiring. Protect wiring from physical damage. Damaged wiring can lead to insulation breakdown, short circuits, and flashovers. Route wiring away from sharp edges, moving parts, and other potential hazards. Use conduit or other protective measures to protect wiring from physical damage. Use appropriate grounding and bonding techniques. Proper grounding and bonding can help to prevent electrical shock hazards and reduce the risk of flashovers. Follow all applicable electrical codes and standards when grounding and bonding electrical systems. Ensure that all electrical equipment is properly grounded. This includes connecting the equipment to a grounding electrode, such as a ground rod or a building steel. Bond all metal parts of the electrical system together to create a low impedance path for fault current. This can help to prevent voltage buildup and reduce the risk of electrical shock. Use ground fault circuit interrupters, or GFCIs, to protect personnel from electrical shock hazards. GFCIs are designed to detect ground faults and quickly interrupt the circuit, preventing electrical shock. Install GFCIs in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Regularly test GFCIs to ensure that they are functioning properly. Use arc fault circuit interrupters, or SIs, to protect against arc faults. SIs are designed to detect arc faults and quickly interrupt the circuit, preventing fires. Install SIs in areas where there is a high risk of arc faults, such as bedrooms and living rooms. Regularly test SIs to ensure that they are functioning properly. Follow all applicable electrical codes and standards. Electrical codes and standards provide guidelines for the safe installation and operation of electrical systems. Follow all applicable electrical codes and standards to ensure that the electrical system is safe and reliable. Regularly inspect and maintain electrical systems. Regular inspection and maintenance can help to identify and prevent electrical hazards. Inspect electrical systems regularly for signs of damage, wear, and tear. Perform maintenance on electrical systems as needed to keep them in good working order. Keep electrical equipment clean and dry. Dust, dirt, and moisture can damage electrical equipment and increase the risk of electrical hazards. Keep electrical equipment clean and dry to prevent damage and hazards. Avoid overloading electrical circuits. Overloaded circuits can lead to overheating, insulation breakdown, and flashovers. Avoid plugging too many appliances into a single circuit. Use power strips with surge protection to protect against power surges. Power surges can damage electrical equipment and cause fires. Use power strips with surge protection to protect against power surges. Turn off electrical equipment when it is not in use. Turning off electrical equipment when it is not in use can save energy and reduce the risk of electrical hazards. Unplug electrical equipment during thunderstorms. Lightning strikes can cause power surges that can damage electrical equipment and cause fires. Unplug electrical equipment during thunderstorms to protect against power surges. Be aware of the signs of electrical hazards. Signs of electrical hazards include flickering lights, sparking outlets, and burning smells. If you notice any of these signs, contact a qualified electrician immediately. Never attempt to repair electrical equipment yourself. Electrical work should only be performed by qualified personnel. Never attempt to repair electrical equipment yourself. Contact a qualified electrician to perform any necessary repairs. Use caution when working around electrical equipment. Always use caution when working around electrical equipment. Wear appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash suits. Follow all applicable safety procedures. Report any electrical hazards to your supervisor or safety manager. Reporting electrical hazards can help to prevent accidents and injuries. Regularly review and update electrical safety procedures. Electrical safety procedures should be reviewed and updated regularly to ensure that they are effective and up to date.